So we're gonna continue on with our parabola lesson, and we're gonna start with a question that really belongs on Tuesday's lesson. So right here, I need you guys to tell me what kind of a parabola we're working with, so we're all looking at the right formula. If the x is being squared, you have a vertical parabola. That's an R. So what I like to do is write the formula right above it, so I can see like who matches up with whom. So x minus h squared equals 4p times y minus 2. The extras are back there, but I think you have one. But it's okay. You can get another if you need one. All right, so I need to find a whole bunch of things, guys. We need to find the vertex. We need to find the focus. And notice I'm trying to keep with the same color scheme that I have been. Oops, not there though. Because when I write these on my graph, it helps me if everything kind of matches. So focus, next we would find the directrix. That is an E followed by a C. I don't know what's happening to my handwriting. It's extra bad. The axis of symmetry. And then the other thing I'd like you to find with me is another ordered pair besides the vertex that we can use to plot, and then we'll use symmetry to plot another one, which means that we're going to want to rearrange the equation for y. We're going to want to solve it for y. Now, as we do a problem, actually two problems today, I'm going to go back and see if you guys have put together the shortcut for how to graph these. But for some of us, me included, the shortcut is not worth it because I just get more confused sometimes using a shortcut. Is there no extras back there? No? Alright, so let's be using our gut instinct on the vertex, guys. The vertex is always located at h comma k, and that's always x comma y. So it is at 1 comma 2. Very good. Built-in negatives on both of those because of the parentheses set and the way the formula works. So the formula for focus, which you guys don't have to write it down, but these are your notes. Yeah, the focus is at h comma k plus p. That's my issue too. I always forget. So I go back up to my formula and I look right here. 4p is 8, which means p is 2. So when I go to find the focus location, it's at 1 comma and then 2 plus 2, better known as 4. We're on turn the page, 2 pages maybe. Worksheet 4. Now, when I go to graph this, we're going to look at this in terms of a conceptual take. Like, we're going to look at the distance of P being like the distance from the vertex of the focus and the directrix. Speaking of directrix, the formula for directrix is a line. And for these kind of parabolas, it's at y equals k minus P. So for us, that would become y equals 2 minus 2, better known as 0. The axis of symmetry for a vertical parabola cuts through the vertex. It is at x equals h. So for our parabola, that would be x equals 1. And then while we're finding things, can you guys help me solve for y? So think about the steps you would do to get this y by itself. She's so affirmative today. Now I'm trying to do this without showing a bunch of steps because I know you're going to run tight on room here. Instead of dividing by 8, what I'd encourage you to do, Daniel, is multiply by 1/8. Yep, so stick the 1/8 in front of this term and leave it there. So the 1/8 is going to stay in front of the x minus 1 squared. And then the last thing you're going to have to do to isolate the y is add the 2 over. I think so. Wouldn't that be nice? So now as far as the ordered pair goes, you guys are going to control the x's. You can plug in technically anything you want for the x, but I would really like it if your math came out nice. The only thing you can't plug in is the vertex. So, oh man, what if we did like a 5?
5?
Yeah. Why would I do a 5? Because 5 minus 1 would be 4, and 4 squared is
2.
16. 16 times 1/8 is pretty, right?
2. And plus 2 is 4.
Yeah. Okay.
5,
So you're like, how did I magically come up with 5? Well, I've lived a long life of trying to make my life easier. So I was kind of looking ahead at the math I was trying to do, and I was like, man, I really want this number to be, I think about my squares, like, who would I love to multiply by a 1/8? 16. So I was like shooting for a 16, trying to figure out how to get there. So we plugged in a 5 here, and obviously you guys can just type this in the home screen, or you could do some cool mental math. But yes, that does come out to 2 plus 2, which is 4. All right, so let's get to the plotting. We have a vertex at 1, 2. we've got a focus at 1, 4. So I would love for you guys to indicate the focus, not necessarily by a point, but maybe use a star, because I don't want you to get confused and think the focus is part of the parabola. Now the directrix is a line, so it should look like a line at y equals 0. Happens to be the x-axis. The axis of symmetry is also a line. I don't really like to draw those as lines, though. I like to draw them as like dashed lines, but it doesn't really matter. It's just a visual cue for me, because that's symmetry line. I just got like a wave of migraine. Oh no, stop. We're good. I must plot parabolas. Okay, 5, 4. Plot the point 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Now, if I look at the equidistance from the line of symmetry, he's 1, 2, 3, I can't count. 1, 2, 3, 4 points away from the center there. So I travel this way. 1, 2, 3, 4. And then I make a beautiful parabola. Oh, that's pretty good. It's a little choppy, but
the first
okay.
side was the right side of it's prettier.
Yeah, it's looking a little taxicab geometry style. There's some, you don't know what this is yet, but there's something called taxicab geometry where you can graph all of your shapes, but you can only make like 90-degree turns, like a taxi in New York. It's actually pretty interesting. So like a circle would look like a square. Like a parabola would look really weird, look like a weird like U thing, like field goal post. So I had a whole unit in college where we did taxicab geometry. I thought it was fascinating and very strange. Okay, so guys, this is new today, kind of. It's putting some old topics together with a new topic. Notice this is not even close to the form we want. We're going to have to complete the square. So, first thing you might want to do is figure out who you're working with. We have a y term that is being squared. So if I think about the formula I'm shooting for, I want this guy to look like the horizontal parabola formula. Yep. So this is what I have to keep working towards. Y minus k squared equals 4p times x minus h. Not squared on that last one, right? So normally what I tell you to do is move everything that's not a y to the other side, which I did in first hour. Do you want to do that? Okay, and then you're going to like laugh at me in a minute. Okay, so y squared plus 6y, and then we're going to complete the square, so blank. Brandon's like, don't do it. All right, so then I moved the 9 over here, so I subtracted 9, right? I moved this guy. So that's like a 3 minus 12x now. But then I got to balance out the completing the square with a blank, and this is where like Brandon was looking ahead, and he was like, oh no. What's going to go in the blank? A 9. Uh-huh, you need that thing I just moved? So like, I'm taking away a blank, I'm adding a blank. Stupid. So in hindsight, I should have just kept the 9 where it was and just used that to write the binomial squared. But whatever. Potato, tomato. All right. I could have, if I knew this was the completed square, I could have just said y plus 3 squared and then left it. Oh well, you live and learn. All right. So right here, guys, this is going to factor into y plus 3 squared. And then over on this side, obviously the 9 and 3 are going to collect to make a 12. But knowing what I want this to look like, I'm going to write the x term first. I'm going to write it as negative 12x plus 12. And I think we're still not there. This does not look like this. We have to factor out something and make sure that the x... Just a 12?
A negative 12.
A negative 12. There you go. Factor out a negative 12.
Oh, because otherwise I would leave the negative 12. Yeah.
Truth. So we need this x to have a coefficient of 1. So whatever's in front of it has to be factored out. Can't have a negative or anything other than a 1. Yep. So, da-da.
Now it looks like it.
Now we're perfect. This is clearly a horizontal parabola. So we can go now, start over, and find everything. Isn't this going to be great? All right, hold on, Skippy. All right, he says p equals negative 3. This is where he found that. He said negative 12 is the value of 4p. So p does equal negative 3. What does that tell you about your parabola? Just give me a little foreshadowing here. It's horizontal, so it's going to open to the left. All right, so keep that in mind. Where's your vertex? Located at what ordered pair? Because the y is squared. If you look at... Right, but if that variable is being squared, that's the transformational shift. So it's this way, is the shift. Look at your formulas. The horizontal ones are y minus k squared is the start. And the vertical ones are x minus h squared. Yeah.
I see.
All All right, so the vertex is always located at HK, which is always XY, so don't get that confused. So it's still a 1, -3. Let's talk about the focus point, and let's go find everything. So I need focus, I need Directrix. I need the axis of symmetry. Eventually, I'm going to want to rewrite this guy in terms of x. So I'm going to rewrite it as x equals and then a big mess. And then I'm going to ask you to find another ordered pair. And then we'll talk about a shortcut after we do this one. All right, focus. Like literally, focus. What is the focus? Okay, what was the formula for focus? For this? For a horizontal parabola, h plus p, comma k. So to find that, and I think we recall that p was -3. So 1 plus -3 would be a -2, and then comma k would be a -3. The Directrix for this kind of a parabola is that x equals h minus p. So x equals, I lost h, here we go. H is 1 minus -3 would be x equals 4. The axis of symmetry for this kind of parabola is at y equals k. So for us, that would be y equals -3. Now, what I like about these, because there's a graphing component, if we were to mess something up, we're about to figure it out. So we have a vertex, we think, at 1, -3. You have a focus at -2, -3. I got confused for a minute, but then I remembered it's horizontal. We have a Directrix line at x equals 4. 2, 3, 4. An axis of symmetry at y equals -3. So everything's kind of lining up where it should be. This is going to be the vertex of our parabola. It's going to be opening this way, so it hugs the focus. Yeah, that's what I was anticipating. All right, let's talk about how we graph now. So if you could help me rearrange and solve for this x. First thing to do is get rid of that -1/12. So we'd multiply by a -12, yes. So we'd multiply by a -1/12 to the other side. Leave it in front of your factor of y plus 3, quantity squared. And then add that 1 over. Okay, now be careful. This time you guys are choosing y values. So whatever you come up with, make sure it goes in the y coordinate. 1/12 tells me I really would love a 36 next to it. Can you make that a 36 somehow?
I mean, you could do -9, but...
You could do -9. How about a 3?
That doesn't fit.
Wouldn't a 3 be beautiful?
Oh, it would.
Why are you so negative, man? All right, 3 plus 3 is 6. 6 squared is 36. Your wish is my command, teacher. There's your 36. All right, so -1/12 times, yes, this is 3 plus 3 squared, which is 36, plus 1. So you got what? -3 plus 1. You could crank that whole thing in your calculator's home screen. You do not have to like mental that on your test. What? -2, yes. So -2, 3. I was like, wait, what? 1, 2, 3. Here's a point. Now, as far as symmetry goes, if I traveled up, let's see, 1, 2, 3, 4, 5, 6 units from the axis of symmetry, if you go down 1, 2, 3, 4, 5, 6 more units, there's your symmetrical point. Connect and make this beautiful, okay. These are big, ugly parabolas. What made this one so fat?
Why do you make them so? Like, all of them are super fat.
Yeah, well, we are giving you what we determine nice p-values. You've had p-values of like -3, 2, 5, 4. Well, in a skinny parabola, you have very tiny p-values, like 1/8, 1/16. To do math on that and to measure a distance of 1/8 is very tiny. So we're giving you examples where it's much easier to see the p-value distance. Speaking of that, are you seeing a distance of 3 units from here to here?
Yes.
And also from here to here?
Yes.
It's working out beautiful. Okay.
Can we take the test now?
No, we have to learn something really exciting and more. Can we talk about shortcuts? Y'all love a good shortcut, right? Have you noticed the last 2 questions we've done? The points that we came up with were directly across from the focus. Did you guys notice that? And that just happened to work out because your teacher made it so. I was like, give me a good number. And the first good number we could come up with happened to be across from the focus. Same thing over here. The good numbers that you came up with happen to be across from the focus. Let's see if we can come up with a shortcut here, guys. On this example, you traveled 1, 2, 3, 4 units this way, and 1, 2, 3, 4 units that way, for a total of 8 units. Does 8 stand out to you anywhere in this formula? Okay, let's test our theory out on the next one. You traveled 1, 2, 3, 4, 5, 6 units up from the focus, and 1, 2, 3, 4, 5, 6 units down from the focus,
No.
for a distance of 12 units.
No.
Yes.
Seriously?
So that is the shortcut, okay? So if you're like, oh man, I hate rearranging the equation,
That's crazy.
then you can do that.
I can just,
You can.
I just need to plot.
Well, so
Focus.
here's two things that have to happen. One, you have to have the focus found and plotted.
Yeah. Focus.
Okay.
That's
The other thing is, you're really hoping that number's pretty. Because if it's not pretty,
Okay. But
like if it was a 1/2,
you could do 1/2. You could do 1/2.
well, how would you travel?
Half.
No, not half. You travel a fourth and a fourth,
Right.
which isn't great.
It's not great, but it's.
But it's a point. I mean, I couldn't count you wrong if you labeled it.
Like, right.
Yeah, I'm with you.
So we can do that instead of having to rearrange.
Yeah. Yeah. Now for me, there's just so much going on that creates a problem
Wait,
for
but
me.
do we still have to show.
No. Nope. If you choose, here's what I'm looking for on the test: an accurately graphed parabola.
That's it.
So we don't need to show the
I need to see 3 points.
y equals.
Nope. So if you want to skip this part, I'm okay with that.
I'm just
But you need to give me the world's pretty guess. I'm just gonna guess. All right, just for that, let's do something fun.
I'm a very good guy.
Number 3. Are we on the back now, or are we still on the front? Still in the front. Okay. Number 3, we've got not completed. All right, we need to complete the square. So what I need is all of your x's to one side, and because the x is being squared, this is what we're shooting for, guys. X minus h squared equals 4p times y minus k. I need it to look like that. All right, here goes. Bring your x's together and bring everything else to the opposite side. So that 21 needs to move. So your x's, everything moves away from the x. So all the x terms, so this will be now a plus 6x, right? We're going to complete his square. And then on the other side of the equation, you're going to have everything else. So you've got a negative 20y. And then if you subtracted this 21 over, now you have a negative 89. But don't forget, and I almost did this first hour, I have to balance. So what goes in that blank? It's a 9, yeah. So the reason you completed the square is so now you can write this as a squared quantity. And then over on the right-hand side, you got a little bit of simplifying to do here, guys. This is negative 89 plus 9, so that's negative 80. I'm going to kind of sneak in a little line here. Yeah, because Daniel says we got to factor something out of that. You have negative 20y minus 80. He says factor out the negative 20. So that leaves me, careful, this leaves me with y plus 4, right? Because of the negative negative. And ta-da! You're in the formula that you needed. Just like that. Aren't those lovely? Okay, now, because I keep forgetting it, can you guys tell me the value for p?
P equals 5. Negative 5.
Good, negative 5. So with this being a vertical parabola and a negative p value, tell me how this parabola is going to look.
Well,
It's going to go down.
It's going to, yep. Jeez, are you in a race against Daniel today? It's going to be reflected across here. Okay. Whew. All right, so where's the vertex? Let's start there. Daniel's just being quiet now. He doesn't. Negative 3, negative 4. You've emasculated him now. Let him have one, okay? Let's talk about the focus. Poor kid. So a vertical parabola, I'm stealing this off my formula card if I'm stuck. But this is where fluency comes with practice. I don't want you guys like scrambling on your test on Thursday, going back to your formula card for every little tiny detail. You're gonna roll out of. You're gonna. Okay. Calm down. I don't want you on your test having to go back to your card for every single piece of this conic because you're going to run out of time. And when I keyed this test, it took me 17 minutes going at a moderate teacher pace, which means we always give you guys like double what it takes us, and we feel like that's an adequate amount of time. But the kid who doesn't practice this and like literally has to like go back to the formula card for every single calculation, they're going to run out of time. Like a lot. All right, focus. Vertical. What I was asking for was the formula. So the focus is at h comma k plus p. So for us, that would be -3 comma, and then -4 plus -5 is -9. Very good. Like 4 years ago, he got it. -9. All right, Directrix. I'm scared. Okay, Directrix is the formula y equals k minus p. So watch your negatives here, guys. K minus p would be -9 minus -5. So that's -4. Ooh, Abruzzo got that one.
Good job, Mrs. Abruzzo.
Thank you. All right, the axis of symmetry. Whoops, of symmetry. I don't really care how you abbreviate that, but it is in the form x equals h. So for us, that would be x equals -3. And let's graph everything. And if you want to try to take the shortcut this time, you can, because you definitely have everything you need. So as I plot things, they should be making some visual sense here. -3, -4, right there.
So long as I have the points and tell you what these points represent.
Yeah.
I'm solid.
Yeah.
Even if it really doesn't look that symmetrical. Because it really did. This does not look very
Oh,
symmetrical.
well, what's the problem, man?
The problem is I suck at guesstimating.
Oh, yeah, that's one. Oh, that was the one I got, too. Oh. This didn't even make sense, Abruzzo. Oh, I was using 9 instead of 4. Stupid. Why you guys let me have my moment? That was really sweet. Oh, gosh.
I just didn't want to ruin it.
I guess.
Because I'm just a sweetheart.
You guys are very
Who lets people
accommodating.
answer.
Yeah, right? All right.
Yeah. I don't think we did. There's still time.
Okay, so if you're taking the shortcut, you're checking out this number in front, which is a 20, and you got to splitsies that. So you got to go 10 units outside of the focus. Y'all, you're going to run out of room.
That's
You can
why
kind
I
of
did
find
what
one
I
of
did and
them,
made it look very
right?
lovely.
Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretend 10's over here. And then, yeah, that's not symmetrical at all. Okay.
No. That's what happened to mine.
Well, then I understand what you're talking about now.
But I know where the points are because I labeled them.
Right. So on the test, I wouldn't do that to you. I'd make sure whatever you're about to graph fits on the graph appropriately. For my friends who don't like this shortcut method, you would have to solve for the... Ooh, that didn't help things. My pen connected my points by accident. So let's get rid of that. Well, what we found is if you start drawing off the screen and then you don't tap somewhere else and then you draw somewhere else, it makes like a connection line. I don't know why it does that. Like, what would I possibly want that tool for? But it does. I don't know.
I doubt it's a tool that they have.
It's probably just a programming, like it doesn't realize that I picked the pen up. So, anywho, if I'm solving for y, those of you who don't like that, shortcut method, you would hit everything each side by a -1/20. You would keep that in front of this parenthesis set, x plus 3 squared, don't distribute, and then you'd subtract the 4 over. So when I was asking my students last hour about what would be a really good number to plug in for x, I would love this thing to be a 100. I'm thinking about my perfect squares that I wouldn't mind multiplying by a 1/20th. 100 seems like a good choice, right? So I went with 7 for x, and then that gave me 7, -9, and then we realized, oh my gosh, I can't graph that, and then it ended up looking like that. Yeah. All right. Go ahead and skip with me to number 5. Number 5 is very much like the question that you're going to see on your test, which I really like this question. And you have to decide whether you want to be conceptual or a formula baby. Was that not the right number?
How do you know where you're... Yeah, how do you
Oh.
write so beautifully?
Oh, thank you. So when you hover like really close to the board, that thing shows up. Like I'm not touching the board, I'm just hovering. So those little cursors here. and then I just
I
write.
don't think I'd be very good
Do
at
my thing.
coordinating, like knowing that, like watching the screen and being kind of like.
I had students in my Algebra 2, they always want to write on this, so we have an activity where like I take a test and I screw up and then they have to play teacher and grade it. They really like that.
I want to do that.
Well, no, I let them use this.
Why didn't you let us do that last year?
I dreamt it up this year. I was like, oh man,
She still has time.
maybe during like final exam time.
Before Daniel.
Before Daniel leaves. So I let them have the board, and they were so cute. They're sitting there like looking at the board like this. I said, "What are you looking at?" Like there's nothing on the
They're looking
board.
at their reflection.
Right. I'm just like, it was very adorable. They tried. Okay. This is a good representation of what I might ask you to do as far as like writing an equation. There's some harder ones coming up though, so this is the easier one. I think taking this in the conceptual route would be much smarter than using the formulas, but let's see. I still want to start with a graph. Vertex at -2, 4. A focus, which I'm going to call like a little red star, at -2, 3. So I don't have a good graph right now, but you're going to have an upside down z parabola. Okay? You with me? Because it's got to hug the focus. So you have a vertical parabola, which is in the form x minus h squared equals 4p times y minus k. Y'all, I think we have everything we need. You need h and k, and you need p. Well, by definition, p is the distance from the focus to the directrix.
How right off the bat did you get that it was going to be vertical?
Just because of the nature of the parabola needing to hug the focus. So if they're lined up this way, it's a vertical parabola.
Oh, okay.
Okay, now I'm going to 1 up your p is 1, and I'm going to call it -1. Tell me why. It's reflected. So if you're going to use this method, the conceptual method, the graphing method for figuring out p, you have to remember that a reflection would look like a downwards parabola. And if it's left, that one's got a negative p value as well, yeah. So you got to be a little careful. So x minus h, we already knew h and k, they're right there. So x minus a -2 would be x plus 2 squared. We just decided p was -1, so 4 times that would be -4. And then y minus k, which we already knew the k was a 4. And then kablamo, we're done. Now, this is where, yeah, right? That's nice. So if you had to graph it, this is where you might make a decision as to how you wanted to graph it. Ooh, why did I erase my vertex? That was silly. I also erased my focus. Gosh, be golly. Okay. Can you use a shortcut with me to plot some points? So we're going to travel 2 units in each direction from the focus.
Wow.
And then I got a beautiful parabola. Oh, I missed that one though.
I did too.
And I don't need to find Directrix and stuff because they said not to find anything else, so I'm done.
I missed it by just that.
Just my left side was strong, and then I got wonky on the right side. All right, this is where it gets kind of gross, guys. This is it. Why are you? She's like a chimpanzee behind Cameron, just picking at the poor boy all day. Okay. Guys, take a look at the clues they give you here.
She just called you a chimpanzee.
She is just like picking at him the whole hour.
I actually don't see but I refrain from touching until now.
Do we have to have a keep your hands to yourself conversation? My goodness. All right.
Just like
The
my shirt tie.
Did you poke a hole in his shirt?
No, the only piece of tape that's
Yeah, that's tape.
That's
So
what
he's got like a hole that.
Oh my gosh.
I had to be innovative in the first time. That's just how
Improvise, adapt, overcome.
Okay. So guys, this clue about it opening to the right,
Oh, the tape's nuts.
it got iron. It's from the dryer. It heat sealed it now. It's never coming off. All right. So opens to the right, guys. That tells you 2 things, 2 very important things. First of all, it tells me what kind of parabola I have. If it opens to the right, we're looking at a sideways parabola, right? So the y minus k squared equals 4p times x minus h. And the fact that it opens to the right tells me that the p is a positive number. That's very important in a minute, or 2 or 3 or 4. We'll go 4 minutes. So this ordered pair, we've never had a question in conics where they just randomly give you an ordered pair.
8 -7.
And that's XY.
That doesn't fit on here.
I know, I apologize, it doesn't fit.
What is weight is half?
You can count by twos. I'm not gonna, because you know I hate that. I'm just gonna fudge it in. But I'm actually not ready to graph yet. I gotta figure some stuff out. I'm not gonna be able to conceptualize this one. So the focus is at the ordered pair 2, 1, given to us. Can somebody tell me the formula for focus on a sideways parabola like this?
H plus P.
Comma K, yep. So here's what I just learned. K is 1. I know that much. And I also just figured out, although it doesn't seem very helpful right now, H plus P is 2. So I'm going to write those two things down. So K is 1, and H plus P is 2. This seems very important, because it's going to go right there.
So it has to be positive.
I need to figure out P, and I need to figure out H. I'm going to need to figure out everything. Here's what I want you to do. We're going to have to substitute. I want you to solve for H. Oh, no, excuse me. Yes, solve for H. The other way would be much harder. Solve for H. So H equals 2 minus P. Very good.
Oh.
Okay. Keep that in your back pocket for a minute. So let's go to our equation here,
That sounds terrible.
and let's plug in everything we possibly know, including the random XY ordered pair. So we know Y is -7.
Minus 1.
We just found out K is 1. That quantity is going to get squared. I have no idea what P is, so just leave it as 4P. Good call.
And 8 minus 2
Ah.
minus P.
Oh, no. All right, 8 minus H. This is where the problem comes in. H is a quantity of 2 minus P. So you got to remember like these parentheses things, yeah, and distribution of them.
Ugh.
All right, guys, this is a lot prettier than it looks, but spoiler alert, you're going to get a quadratic in a minute.
I knew that.
All right, here goes. 8 squared is 64. Leave the 4P alone for a minute. Can you clean this up? No, double negative here, so this is like a plus P on the end. Can I just call that?
6 plus P.
Yeah, I'm going to call it P plus 6, but yeah. So do you see the quadratic forming? You're going to distribute the 4P. And because it's a quadratic, and I know how we solve quadratics, I'm going to move everything over to the right-hand side, so I'm going to subtract the 64 as well. So 4P squared plus 24P, and then yoink that 64 over, minus 64. Ladies and gentlemen, this problem's hard enough. Can you make it a little easier?
Divide by 4.
Yes. Pretend that didn't cross off my problem. Your quadratic now says P squared plus 6P minus 16. It's not terrible.
8 and 2.
All right, positive
Positive
8, negative 2. I like that. So your two solutions you just got are P equals -8 and P equals 2. However, way at the beginning of the problem, they were telling you that this opens to the right. P must be positive, which means -8's garbage.
This was all for P.
Yes,
Oh my
but look, P is the key to everything right now because you now know H.
Wow. This
Yes.
Is insane.
2 minus 2 is 0. H is 0. You already knew K. We know P. Guys, that's all you need. I'm not going to graph this one, so if you don't mind, I'm just going to like blast my equation across the graph. So the formula is Y minus, who's K again? I lost track. 1 squared equals 4 times P, 8. And then if you wrote X minus 0, I would not count you wrong at all. I like that because it looks like exactly like the right form. But if you just wrote X like a normal human, that's fine too. Guys, that was a hoot. Let's do another. There are 2 on your homework that are like this.
I thought there was no way that we would possibly ever get that.
We'd never get it. You didn't have faith in your teacher to lead you to the...
Obviously, we'd eventually get it.
We'd eventually get there. But it showed up pretty fast, right? Once you got the quadratic, like everything fell into place.
Like,
Yeah.
once you said you're going to get a quadratic, it was like, that's how we're doing it.
It was a lot of work. Now, there is technically a way you guys can conceptualize that. But first of all, remember how it wasn't fitting on the graph to begin with? And that random ordered pair, like... it didn't, because it wasn't the one that was across from the focus. You'd have to figure out like how to back it up, and that just was a lot of work. So the work we did was probably easier than conceptualizing it. I'm going to go with that. It's another one, just like this. This one's not any easier. What are you doing now? All right. Oh, blast. They count by twos. All right, 1, 4. Right there. There's your focus. Not a part of the parabola, but it's your focus. It says it opens down. What does that tell you? That the P is something negative. Also tells you that this is what kind? Vertical. Vertical. So the formula you're going to be using is this guy. X minus h squared equals 4p times y minus k. All right. This random xy ordered pair we're going to use as x and y, just to kind of help us out so we can find p. We're going to end up with a quadratic again like we did the last time. All right. The key to this question is relying on the focus clue. There's some formulas stuck in there if you look closely. The focus we know is at 1, 4. But can you tell me what ordered pair that is? Like what the formula is for that ordered pair? H, comma, k plus p. So we just figured out that h is 1. The other thing we just figured out is that k plus p is 4. So just like the last question, I want you to solve for that last time it was h, this time it's k, solve for the k, and I want you to substitute that in a minute. So first of all, what is this when you solve for k? P, 4 minus p or negative p plus 4, either one. Yes, I'm going to use this version of it. All right, so here's what I need from you. You're going to plug in everything we know. I should color this something else. I'm going to color this red, including this weird ordered pair. All right, here goes. So parenthesis, x, the x value is negative 3, minus h. We just found that to be a 1, quantity squared. Equals, I have no clue what p is, just leave it alone, 4p. Parenthesis, the y value from the ordered pair is a 1, and then you're going to subtract. Now this is where you got to be careful because you're subtracting the quantity 4 minus p. So you got this distribution thing, which I know it's like very tempting to skip a step and just distribute it. Just be careful. You've got, what do we have here? Negative 4 squared, so 16 equals 4p. If I clean this up a little bit, I end up with, let's see, negative 3 and then a plus p, so I'm going to call that p minus 3. All right, quadratic time. We're almost there. Let's distribute the 4p. And since we know we have a quadratic, let's move everything to the other side. So 0 equals 4p squared minus 12p, and then subtract that 16 over. Oh yeah, good call. Divide everything by a 4. I almost forgot that part. So we got p squared minus 3p minus 4. Oh, that's like a baby quadratic.
Negative 4 and 1.
So p minus 4 are your factors, and p plus 1 is your other factor. So your solutions... Yes, we got to throw out the 4, because that's not going to work for something that has to open down. We're going to use p equals negative 1. All right, guys, we're home free. You've got h. You can now find k, because you just found p. So k is 4 minus negative 1. K is 5. Y'all already just found p. It's rock and roll. Plug everything in where it goes. I'm not going to graph this one. I'm out of energy. All right, here goes x minus h. Quantity squared, so x minus 1 squared. 4 times p would be negative 4. And then times the quantity y minus k, so y minus 5. Actually, you know what? I lied. Let's graph this one. Why not? That's okay. You can just watch me graph. It is a thing of beauty. All right, your vertex is at 1. Hey, that wasn't a joke. 1, 5. Oh, but it's counting by 2s, Abruzzo. Be careful. There's your vertex. 1, 5 is your vertex. Now, if I'm using my shortcut, this number that's in front here, splitsies that, and that's how far we move from the focus. So 2 points on each side. But remember, Abruzzo is counting by 2s. So here and here. And then, oh, that's a interesting looking parabola. Hey, but it opens down. You're welcome. All right, so that was nice, right? That was fun. All right, so your homework, the bookwork that's assigned to you, numbers 37 and 41 are like those guys. So you might want to star those, and not because you should skip them, but because you know you're going to have the most fun on 37 and 41.
Look what I've been up to. Homework.
There, girl. Thank you. So remember my speech about fluency, guys? You're going to run out of time on this test on Thursday if you aren't fluent. You need to practice, practice, practice. You got a weekend here. Catch up on... And some of you, I think, need to go back and practice some trig stuff, knowing that that's on the test again. We have 5-3 and 5-5 on the test again, solving equations and then like the weird swapping and solving equations. All right. Good luck, everybody.